We're continuing with question number 2. In part C, they introduce a new particle, Q. The time interval is still the same, from 0 to 4. But instead of being given a table of values, this time we're told exactly how the velocity of particle Q is defined. And so the velocity of Q is also measured in meters per hour. And part C asks us to do two things. The first thing that we're asked to do is to figure out the time interval when the velocity of particle Q is at least 60 meters per hour. So the word at least is important. At least means greater than or equal to, we want V sub Q of T to be greater than or equal to 60. So that's the first part of the question. We do remember this is a calculator question. We use our calculator to find the answer. So let's do so. Turn your calculator on, go to mode, make sure you are in radians. As you can see, I am in radian. Go to y equals. As you can see, I've entered two things. I've already entered the velocity of Q, and I've entered the number 60. Set up your window. Your x's should be between 0 and 4. Your y's, I chose them between negative 10 and 100. It is possible for you to use a different scale. What you have to do is play with your calculator and find your own scale. Now let's graph. There's the graph of the velocity of particle Q. This is the graph of y equals 60. The velocity of particle Q is above 60 when the graph of the velocity is above the line y equals 60. Then go to second, calculate. Intersect. Intersect gives you the point of intersection. I'm going to use the right arrow, and it looks like I got to the point of intersection. First curve, just press enter. Second curve, press enter. Guess, press enter. And we get 1.866. Because I don't want to forget this time, I will write it down and I will be right back. Same procedure, second calculate, intersect, use the right arrow to get to the other point of intersection. You'll get there eventually, just like I will get there eventually. It looks like I'm there. Again, we're going to press enter 3 times, once for the first curve, once for the second curve, and once for our guess. There it is, 3.519. So 3.519. So we're right. V sub Q of T is greater than or equal to 60 from T equals 1.66 to T equals 3.519. The first part of this question is done. We are now ready to do the second part of this question. In the second part, we're asked to find the distance. Be sure that you understand what are they asking for. They're asking for the total distance. So you have to use the formula for the total distance. Total distance is equal to the integral from A to B of V sub Q of T dt. So it is equal to the absolute value of V sub Q of T dt. So in our case, this would be the integral from 1.866 to 3.519 of the absolute value of V sub Q of T dt. Now you will see that I will remove the absolute value. First of all, I'm going to remove v sub q. It doesn't have to be v sub q. It can be any velocity. I'm going to remove the absolute values for our problem. The absolute values for our problem are unnecessary because what do we know about our velocity? Our velocity is at least 60 meters. Well, if it's at least 60 meters, it will be positive, and the absolute value of a positive number will be positive. So when I enter this into my calculator, I'm not going to have the absolute value. I'm just going to use regular v sub q of t. So let's use our graphing calculator to find the distance traveled, and then we'll be done with this problem. We go to y equals. We do not need to know about y equals 60. We clear, we graph. Calculator takes a little bit of time, no problem. We press second and calculate. Second, calculate. And then we want to find the area underneath the curve, which represents the total distance. Again, like I said, I do not need the absolute value bars. You can see the curve is above the graph. So the values of v are positive. And so we go from 1.866 to 3.519. We let the calculator do its work. And we have the total distance traveled is 106.109. And we are done with this problem. So 106.109. And that's it. That's the end of part C.